Now we are going to talk about the factors that affect current flow. What causes the current flow to be high and what causes the current flow to be low, or even there is no current flow? There are two factors, which are number one, the energy of the charges, number two, the properties of the objects that the charges flow through. For number two, about the properties, we said that we have two types of materials that can cause charges to flow, either to be conductors or insulators. And conductors, their atoms contains electrons that can move freely. They are not tightly bound to the nuclei of these atoms. And for the insulator, the electrons are tightly attached to the atoms, so they are not able to move freely and carry the electric charges. Now, what about the energy of the charges? At the beginning, I told you that the more exciting slide is the slide which is higher or lower. For sure, the higher the slide, the more exciting it is. Why? Because as you are standing up or at the top of the slide, you have more gravitational potential energy. So imagine that you have two slides, for example here, one long slide and one short slide. Take care, the height here is high. For example, let's say that it's 2 meters and you are standing here, so you have more gravitational potential energy. But here its height, for example, is 0.5 meters and you are standing here, so you have less gravitational potential energy. So as you are moving from the top of this slide down, you will find that you have more kinetic energy. This gravitational potential energy has been changed into kinetic energy. The more kinetic energy, it means that you have more energy to move and you can move more than the other slide. On the other slide, you have less gravitational potential energy. Why? Because of your position, it's not too high. So the amount of gravitational potential energy that you have, it will be translated into kinetic energy. So which one will have more kinetic energy, the first one or the second one? For sure the first one, because from the beginning you have more gravitational potential energy because of your site or your location at the top of the slide. This slide is higher than this slide, so you have here more potential energy and here you have less potential energy. The more potential energy, it will be translated into more kinetic energy, so you will move faster. And here the less potential energy, you have less kinetic energy, so you will move slower. So you can compare between these two pictures. Which one is more exciting for you, do you think? For sure the first one on the left side. Why? Because it's high, because of its height. You can imagine how many stairs you will step on in order to reach the top of the slide. Too many. What about here? There are just some steps, for example 5. So here your position will be higher than here, right? As you have higher position here, so you will have more potential energy, so it will be translated into more kinetic energy and you will move faster, so it's more exciting. But for here you have less potential energy, will be translated into less kinetic energy, so you will move slower and it's not exciting anymore. This is applied for the slides. Can we apply the same for the batteries or the electric charges? Yes. In electric charges flow because of the difference in electric potential energy, or potential energy from an energy source like a battery gets converted into different types of energy. As we said that the source of electricity in any circuit is the battery, right? That contains inside many charges that will flow through the wire, right? For sure the circuit has to be complete, uncut or unbroken, right? So here, if there is a difference between the potential energy inside the battery and the potential energy along the wire, so the charges will flow the same like the slide. If you have more potential energy, so you will have more kinetic energy and will slide faster. The same here, if the battery contains more potential energy, or the charges inside the battery contain more potential energy, so it will be translated easily to another form of energy, and the charges can move freely. So, for example, here in the electric circuit that we have discussed before, in this electrical circuit, we said that this is the source of charges, which is the battery, and the charges inside the battery contain potential energy, right? This potential energy will be translated into another form of energy, which is light energy. The higher the potential energy, the more light you will get. The same like the slide. The higher the potential energy, the more kinetic energy, so the higher the speed that you will move by. Also for the electric circuit, the higher the potential energy, the more the energy it will be translated into, for example, the more light. You know that we have different kinds of batteries with high potential energy and batteries with low potential energy. If you are using a battery with high potential energy, so the light bulb will light more and for longer time. But if the battery contains potential energy which is low, the light bulb will light a little bit less than the previous one, and it will not last for a long time. How can we express or say that the potential energy inside the charges are high or low? We can we can describe this as the voltage. Voltage is the difference in electrical potential energy per charge between 2 points in a circuit. For example, there's a wire here, and we have a charge that's passing through this wire. Okay, for example, the potential energy in this part is, let's say, 3 joules, and then it passes to another point, okay, in which the potential energy will change into 1. The difference between them per one charge equals 2. So the voltage here equals 2. So the voltage is the difference in electric potential energy per charge between 2 points in the circuit. The higher the voltage, the more speed of flowing of charges. As you see here, there are some different types of batteries. This is a battery with 4.5 volts. Volts, these are the units used to describe the voltage, right? This is the voltage of the battery, 4.5, and this battery has 6 volts, and this one 9 volts, and this one 12 volts. What the meaning of these words when I say that? For example, this battery's voltage is 6. It means that the difference in electric potential energy per charge, one charge inside this battery, equals 6 per charge. Take care, I'm talking here about each charge. So the voltage describes the potential energy of each charge. Again, the voltage of the battery describes the potential energy for each charge. Here, if you have batteries at home, you can check them. You will find that on each battery it's written the volts, the voltage of each battery. Here it's 1.5, as you see inside the circle. When I say that the voltage of this battery is 1.5, it means that the potential energy for each charge inside this battery equals 1.5 volts.